Hey everybody, welcome on into Albert's Weather Classroom. It's day 7 of the classroom, and today we head to space. Hope everyone is having a fantastic afternoon. It's beautiful. If you're watching us from Central Texas, the Austin area, sunshine is back after a gloomy Monday, wet Monday. How's everyone doing? Just checking my audio, make sure I can... There you go. Yay, audio is working. So it only took me a whole full week, everybody, to figure out how to get rid of the buzz in my microphone and how to turn up the volume. So hopefully I sound a lot better at your house. So as we kick off every Albert's Weather Classroom, we do roll call because I want to know where you're watching from. And I also like to share some pictures of some wonderful students that have been checking on in. Of course, you can send me your photos to KVUE Albert on Instagram, on Twitter, on Facebook. KVUE Albert of you watching our lessons. There's some of our friends watching from yesterday. Aaron saying that Austin, first grader at Cedar Park, is watching. Oh, and Adam watching from Round Rock. Katie's watching. Hey, Katie. We've got Willa, who's in pre-K, and Jacob, a third grader, all out of Buda area. Jordan is watching from Round Rock. Michael, Dominic, and Anthony, they're back again. Hey, guys. They're back to watch Space Day for day 7. We've got someone watching from Andersonville. Hannah says 3-year-old and 8-year-old from Lakeway watching. Great Hills in the house. Hutto is watching as well. Madison is in 4th grade from Hutto. So keep telling me how things are looking and sounding. Let's look at a few more pictures before we get into the lesson. Get a few other folks to come on in. Roberto in Fort Worth is watching. Mariel is watching from San Marcos. Grant, a 5th grader in Georgetown. There's some of our friends that have been watching the last several days. A lot of you have been watching Albert's Weather Classroom at lunchtime. This guy's doing it right. Mac and cheese, Albert's Weather Classroom, they go hand in hand. All right, so let's get started, everybody. Today, we step out of the world of weather, and we're going to talk about space. I've got my Star Wars shirt on. So it's a special day. It's Space Day. I will say this, a couple of things right off the top. If you missed any of the lessons from last week or even yesterday's lesson, it's all provided in the link, the KVUE.com link within either Facebook or here on YouTube, or you can search YouTube, just Albert's Weather Classroom. All of our past lessons are there. Last week, Monday, Introduction to Meteorology, then the atmosphere on Tuesday, reading Wednesday, severe weather on Thursday, last Thursday. Then we had a forecast Friday. Big thank you to everyone who's responded about the forecast Friday. Really enjoyed that. Yesterday, it was career day, the different jobs you can have as a meteorologist. And today we step away from meteorology and we head into space a bit. 2 shout outs. First is NASA for some of these fantastic images that I'm going to show you today. Second shout out to my good friend who's a counselor at Purple Sage Elementary, Miss Rodriguez. Miss Rodriguez, though, used to be a science teacher before she was a counselor, so she helped me a ton with this presentation for the content. And if you are a science teacher and you would like for me to email you this PowerPoint to use down the road, I will be happy to do it because this is a Texas education standards for it. So my degree is in meteorology, the study of weather and climate. And as you go outside of the Earth's atmosphere, I got to study some. So this is a special presentation, not super long either today, but just a little bit of a taste of space. So we'll get into it. Tanya's saying, I love NASA. So many good resources from NASA. So let's talk about space, the universe. And, I've been dealing with science for several years, and this still blows my mind. So think of the universe, right? Made up of billions of these swirls. And this is what we call galaxies. And galaxies are made up of billions of solar systems. A solar system is where we're located. Earth is made up of, it's one planet of several that make up our solar system. We revolve around the sun. We'll talk much more about that in depth. But just to give you an idea just how enormous the universe is, this is just our galaxy, what we call the Milky Way Galaxy. In our solar system, in Earth, located in a very tiny pocket of the Milky Way Galaxy. And how many swirls like this, how many galaxies are out there? Well, conservatively, it could be as small as 100 billion to maybe as much as 400 billion. We don't know. Here on Earth, we look at the night sky like this picture. Maybe it's not this fancy. You need a cool telescope. But you look at the night sky with no moon and it's dark out and it's clear. and you see hundreds, if not thousands, of stars from horizon to horizon. And a couple of those stars are going to be planets, but majority of those stars are suns, just like our sun. And just like our sun, each one of those stars, each one of those suns has planets that are revolving around it. So we only see here from Earth a very small peak of the universe. The universe is massive. It's the biggest thing ever. And it's a big theory that it's continuing to expand. It's continuing to grow. So think of the universe and galaxies like the Milky Way Galaxy, made up of, billions of solar systems, and then suns across just our galaxy, and then just our solar system. So it gives you an idea just how massive we're talking about when it comes to space. Now, coming a little bit closer to home, because kind of a big, and then we're going to kind of get a little bit closer to home. Milky Way, and they have revolutions around the sun. And we'll talk more about that. What's a revolution? What's a rotation? We'll get into that in just a second. So let's just focus in on our solar system. And our solar system's big. Think about it. In human history, humans have been able to go to our moon. And maybe one day, we don't know how long it's going to take. Could take a decade, could take more than that. Eventually, we're going to make it to Mars. Mars is a long way away for humans. But on the grand scheme of things, if we look at the whole big picture of the universe, Mars is like in the next room. It's super, super close, but it takes technology that right now doesn't exist and would take a long, long time to just get there. So imagine us trying to just explore our solar system, much less the Milky Way Galaxy, much less the entire universe made up of tons and tons and tons of those galaxies. So we've got a long way to go when it comes to space science. So our solar system includes the big bright guy out there, the sun, which is a star. We've got planets, natural satellites. That's the kind of the key word there. Natural satellites are the moons. Here on Earth, we have, of course, one moon, but there's some planets that have multiple moons that revolve around the planet. Dwarf planets, and then smaller bodies, which we'll talk about a little later in the presentation. Smaller bodies are like asteroids, meteoroids, and comets. And I had a whole lot of fun putting this together, and a little bit later on, I'll show you the difference between a meteoroid, a meteor, and a meteorite. What's the difference? And that's all coming up in just a few minutes. So let's focus in on the planets. Again, we're just focusing in on our solar system. We have the planets broken up into two groups, the inner planets and the outer planets. Closest to the sun, farthest away from the sun, right? Closest to the sun, Mercury, Venus, here home, Earth, and Mars. And then your outer planets, Jupiter, Saturn, Uranus, and Neptune. Now, Earth is, like my friend Jenny said, Miss Rodriguez said from Purple Sage Elementary, Earth is the Goldilocks planet out of all of them. Right? It's not too hot. It's not too cold. It's just right. Goldilocks from the Three Bears. So we are right in the perfect position where we're not like Mercury. We're not too close to the sun where human life period can't exist. And we're not that far out like these outer planets where it's just too cold. Plus, where we are at, we have an atmosphere. We talked a lot about the atmosphere and the gases that make up our atmosphere on last Tuesday's lesson, if you missed that. So those are the planets, the inner planets and the outer planets. And just to give you an idea, this is where we are. We've made it to our moon. And like I said, in the next room, like right around the corner is Mars. And we're still a long ways away to getting there. Of course, we've had, at least humans getting there, we've had, of course, satellites, exploration satellites that have come all the way out here to the outer planets, and that's why we have some really cool images of that. So let's talk about our solar system and the movement, the motion within our solar system, and the difference between rotation and revolution. And this is actually really cool. So rotation, let's talk about rotation first. Rotation is the motion that planets spin on their axis. Back on last Monday's lesson, we talked about how the Earth rotates on its axis at a tilt, and it's that tilt that allows for seasons. Depending on where we are in the time of the year, it's either winter or it's a summer, spring, or fall. And it's all because of that tilt in the atmosphere. So this is actually really neat. When we talk about rotation, again, we're talking about the motion that the planets are spinning. But take a look at this. Some planets spin faster or slower than Earth. So here on Earth, we know that one full rotation is about 24 hours, one day, right? From sunrise to the next sunrise, it takes 24 hours. Technically, that one full rotation on the Earth axis is 23 hours and 56 minutes. Some planets, though, go a lot faster. So, for an example, Jupiter, one Earth day in Jupiter, because it's rotating so much faster, only takes 9 hours and 55 minutes. But some planets are a lot slower. And look at Venus. This is crazy. To have one Earth day on Venus, it takes 243 days, nearly an entire year, an Earth year, for Venus to make one full rotation. And notice also, this shows you kind of the Earth's tilt on its axis, about 23.5 degree tilt. Planets have different tilts. Look at Uranus, has a completely different tilt. So it's really interesting to see all the different planets. Mars is probably the closest to Earth as far as Earth days go. It takes a little bit longer for one full axis like that, but they're also revolving around the sun. That's what we call revolution. And one full revolution around the sun takes 1 year, 365 days here on Earth. And as we talked about last week on our Monday lesson, as Earth goes around, whenever our tilt is towards the sun, it's summertime. And then when we're on maybe the opposite side, where we're tilting away from the sun, in Australia and South America or in the southern hemisphere, they're dealing with summer while we're dealing with winter. So a little bit of meteorology mixed in with space, but one full revolution around the sun. Take rotation here on Earth, 365 days or 1 year, a revolution around the sun. So I think you'll enjoy this part of the presentation. We're going to talk about the smaller bodies in our solar system. We know we have the big sun. We know we have our planets, the inner planets, the outer planets, right? We've got moons, in some cases, multiple moons that are also rotating around those planets captured by their gravity. But we also have this rock stuff out there, or gassy stuff, which we'll talk about with comets. So we're going to talk about the difference between asteroids, meteoroids, and comets. And I learned a lot just putting this together as well. So let's talk about an asteroid. Asteroids are just big rocks. They're made up of rock and iron, the same material that Earth is made out of, right? All the inner planets are made up of rock and iron. Asteroids orbit the sun, primarily between Mars and Jupiter. In this part of our solar system, we call it the asteroid belt. Okay? So those are asteroids. Now, that's kind of where they are in the asteroid belt. Occasionally, they can wander away from the asteroid belt and they can hit Earth. There is a theory, you've probably heard this before, especially for those that are dinosaur fans, that what caused the extinction of dinosaurs was a big asteroid, a big piece of rock and iron crashing into the Earth and killed off all the dinosaurs. That's why there's no more dinosaurs around. That's a very, very popular theory. Right? Can't prove it, so because it happened so long ago, so that's what we call a theory. It's not a fact, it's a theory. You'll remember that from science class. Now, smaller pieces of asteroids, still made up of rock and iron, are called meteoroids. Meteoroids orbit the sun, just like asteroids and planets, and meteoroids, whenever they enter the Earth's atmosphere, that's when we call them meteors. So when they're out in space, right, and they're just rock and iron, they're meteoroids. Meteoroids. As they get into our atmosphere, we call them meteors. And you'll remember from last week's lesson on Tuesday that these meteoroids will start to burn through our atmosphere as meteors, mainly in the mesosphere part of the atmosphere. That's back on last Tuesday's lesson. And when they burn through our atmosphere, what do? You make a wish. That's a shooting star. So next time you see on a clear night, shooting star, now you know that is a meteoroid coming from space, now termed a meteor, burning through our atmosphere. And as it goes through the mesosphere of the atmosphere, that's why you see that hot color, that streak across the sky, and then you make a wish. You wish upon a star, and it's not a star, it's a meteoroid entering our atmosphere, and it's a meteor. So if the meteor is big enough, right? Big enough, it makes its way through our atmosphere. It's getting shred. It's getting so hot. It makes that little tail. You can see it streak across the sky, and it hits the ground. It hits Earth's surface. We then call it a meteorite. So let's break this down again. Out in space, what is that called? Meteoroid. Burning through our atmosphere, meteor. Hits the ground, meteorite. Meteorite. All right. So meteorites can be as small as pebbles, maybe a little bit bigger, boulders. I have never seen one in real life. Here's a picture from NASA of one that made it through our atmosphere. And again, it's rock and iron, the same materials that Earth is made up of. And it's just a tiny piece of an asteroid that it has made its way all the way to the Earth's surface. So I took a lesson, this is several years ago, how you can tell the difference between a regular rock and a meteorite. And there's really interesting things when it comes to if they're magnetic, if they can scratch porcelain. Like there's a little kit that you can look at. So I wish I still had all that information I'd show you. But if you want to research some more, you can go to NASA's website or go to Google, type NASA plus a meteorite, and you can see all kinds of pictures and learn more about that. So we talked about asteroids. We talked about meteoroids. Now let's talk about comets. Comets are a little bit different. Comets are big chunks of ice and rock and gas. Think of it as a dirty snowball being left over from billions of years ago of the creation of our solar system, suns that are out there just in the Milky Way Galaxy and the billions of galaxies that make up the universe. It gives you an idea just how vast, how large we're talking about. That still blows my mind just thinking about that. So I like meteorology. It's, of course, my career and everything. But if I were able to go back to school, I guess I could. I would totally just dive into this because I think this is just super fascinating stuff. So comets, let's talk about that. We'll kind of look at a picture here, and you'll see that it consists of what they call the head of the comet or a comma of the comet, and then you see the gas tail that points away from the sun. All right. So as the comet travels near the sun, the heat from the sun vaporize the gases, the ice that forms on this comet, and that's why you see that glow. And that glowing material trails behind the comet, what we call a comet's tail. All right. So the famous comet, if your parents are with you or your grandparents with you, they'll remember this one. I was a little too young. I don't remember this. I was only 2 years old when this happened. But kind of a famous comet that a lot of people talked about seeing from Earth was back in the 1980s. I believe it was 1986. And it was Halleys Comet. And Halleys Comet comes by Earth every 76 years. So I'll be 77 years old the next time Halleys Comet comes in. So I believe it's the year 2061. If I remember that correctly. So try to figure out how old you are now. How old will you be in the 2060s? The 2060s are going to be awesome. I'm excited. So this is from space.com. Oh, yeah, here it is. That was a good guess. It's from space.com. They said, quote, when Halley sweeps by Earth in the year 2061, the comet will be on the same side of the sun as Earth and will be much brighter than 1986. So for your parents or your grandparents or your aunts and uncles that may be watching, you can ask them, do you remember Halley's Comet? And they'll tell you, yeah, it was spectacular. In the year 2061, it's going to be even more spectacular just because of this proximity to the sun. And again, that's going to be fun. I'll be in my 70s. How old will you be? Some of you may, let me say, some of you may only, well, you'll be right in that neighborhood, I guess, too, that you're watching. So this was a kind of our shortest lesson out of all of them, just because my discipline is in the world of weather. And I just wanted to give you a quick little taste of space and hopefully encourage you to learn more about space. Ask your parents for a book. Or there's so many great resources online. If you just search anything within NASA, NASA has some fantastic, just anything you want to know about, whether it be about galaxies, the Milky Way Galaxy in particular, our planets, our sun. We can go forever just about our sun, how amazing that is. And also, if you want to learn more about asteroids, meteoroids, or comets, I encourage you to check that out. It's really cool stuff that you. I hopefully just kind of stimulating some thoughts about this, our planetary system, which is massive. And then if you just think about the galaxy itself, it's even more massive than that. But again, just want to give you a little taste space, get some interest going, and let you know about that. I could have gone on forever about that, but we'll leave it to the experts. So here's the plan for the rest of the week. Tomorrow is Reading Wednesday. We have Thursday is going to be all about tropical weather. tropical storms, hurricanes, stuff like that, where they develop, how they develop. We'll even talk about Harvey, which happened a few years ago, and my experience with that. And then we'll wrap up Albert's Weather Classroom on Friday with another Forecast Friday. If you enjoyed last Friday, it's just me and you basically like this, and I'm showing you just different images of what I look at to forecast weather, and we'll dissect what's going on in real time and show you some of the gear. And one, I think, difference from last Friday that we'll do is I'll show you the weather computer that I use to build graphics and stuff, kind of give you a little behind the scenes of the weather software that we use. So anyway, that does it for me for today. I hope you enjoyed that one. Again, quick lesson, 20-minute lesson, and hope you have a good rest of the day. I'd answer